like the pleasure to introduce Paul Mankiewich, Chief Technology Officer for Mobility at Cisco. Paul does lead strategy for Cisco. I think they know a little bit about mobility and how to make this thing happen. Thanks for all your help, and I think you've got your introduction, so I'll just turn it over to you, Paul.
Yes, and you never argue with Siri.
That's right.
Okay, so thank you, that was great. I'm going to take us in a slightly different direction. I'm a technologist. I've been a CTO for as long as I can remember. Not sure that's a good thing. And what I'm going to do is sort of take you on a bit of a trip on what's going on in mobile networking. Now, we all see millions of devices arriving. We see data explosion, all those marketing slides and et cetera. And we experience it every day, as was just said. But what's happening underneath the covers? What is happening to the network to be able to support all of that tremendous advance in technology and applications and et cetera? And to tell you the truth, we're revolutionizing the way we run mobile networks. Within 3 to 4 years, the way mobile networks are deployed, managed, run, optimized will be completely different. Let's see if I can make this thing work properly. So, as I said, the data is exploding. Data is exploding from the devices, from the applications, from machine to machine. We'll talk a little bit about the Internet of Everything. We have a plethora of devices, hundreds of millions of devices will be entering the mobile network, much greater than we have today. And we have to build a network that's robust enough to handle that tremendous influx of devices and data throughput. One of the things that, I've been in this business a long time, and we built data networks actually quite a long time ago off of the voice networks in mobility. And it was one of these things, if those have seen the movie The Field of Dreams, if you build it, they will come, and nobody showed up. We actually built a lot of networks around EVDO and GSM Edge, and all these technologies had incredible throughput for their time, but since there were no apps and no one using data, the throughput was thought to be infinite because the networks were pretty empty. We had a huge business around enterprise. Enterprise users were sort of the first ones to take it up, people doing real estate, pharmaceuticals, technicians in the field. But what really kicked it off was Apple showing up with the GUI on the iPhone. That's my opinion. People will disagree with me. Not the iPhone itself, not big screens, but actually I could touch a button and I could get where I wanted. Remember those old devices? You would hit it 10 times to get to the screen you wanted, and before you hit that screen, you had a traffic accident. So this really making that ease of use and making that user experience better really made the network take off. And that is one of the key themes I want you to take away with today as I get into this discussion. It's the user experience. We've got to continue to improve the user experience in an environment where we're just flooding the network with devices. Also, devices are becoming, there's too many to count the different types. Besides the obvious machine-to-machine devices and Internet of Everything devices, how many different types of endpoint devices do we have today? Everything is being connected wirelessly to this network, anything you can possibly think of. I like to say that, it said this is the biggest, in the intro, this is the biggest thing that's happened since the Internet. If it wasn't for us, there wouldn't be an Internet. Okay, we are what is driving the Internet. Mobility, the untethered, that's what's driving the Internet. And of course, this explosion about to happen, as I said, hundreds of millions of devices are going to hit this network within the next 10 years. Everything you can think of. I remember about 10 years ago, the CTO of HP telling me, the one thing I totally hooked up my house, and this was 10 years ago, and the one thing I can tell you that does not need an IP address is a toaster. And he may be wrong, because we'll probably give it an IP address. Everything you touch will be connected. There'll be sensors all around you to improve your life, we hope, or irritate you in some cases. But we will have hundreds of millions of devices joining this network, all the way from environmental devices, do farming, et cetera. We'll revolutionize so many industries with the ability to automate and bring these devices on the mobile network. Now, remember I said that thing about optimizing user experience? Well, if you're a user, all of these things I have to look at if I'm going to make your experience better. What type of device do you have? What type of technology are you on? Are you on cellular? Are you on Wi-Fi? Are you on small cells? Are you on macro cells? Are you on wireline? Although everyone that's on wireline tends to be on Wi-Fi, but on wireline, right? What session, what are you doing at any given time? What website are you looking at? Are you doing email? Are you looking at a video? Managing QoS. How do I make sure that if you've asked for a certain service, that it actually gets to you? You know, one of the things, in our engineers, we have engineers in the old days that were, the packet core, the core engineers, and then you'd have the radio engineers. And the core engineers didn't realize that if they told the radio to go do something, the radio didn't always do what it was told. So the thing it sent out there never got there. So being able to manage end-to-end that network from the radio all the way through the core, all the way through the application servers and to the end user and also to the deliverer of the content. Location awareness, where are you? What is your presence? And mobility control, right? How do I optimize your ability to roam, to move between different technologies as you're moving through your daily life? What I'm going to do, I'm not going to talk about devices and the plethora of them. I'm going to talk about, since I don't have a lot of time, two underlying technologies that are basically driving the revolution in how we manage and run these networks. I'm not going to talk about small cells or Wi-Fi because they're all buried in here. Because a small cell or a Wi-Fi node unto itself is a cute piece of technology for connectivity, but unless I include it in the rest of the network and optimize your experience, so when you're on Wi-Fi and the Wi-Fi's and you're moving and you need to move to the next place, how do I move you? How do I connect you up so that there's a seamless experience that you're having? So the second one is what we call virtualization and orchestration. How do I simplify this mobile network? Companies like Cisco, Ericsson, Alcatel-Lucent, Nokia, Siemens, Juniper, you could go on and on, build equipment that drive these networks. I'll show you a simplified architecture slide. I think you'll be horrified by the simple part. And so the issue is, how do I simplify this? How do I make it so this network is not an amalgamation of hundreds of different nodes? How do I make it so that it operates much more seamlessly so I'm not constantly provisioning all these different nodes, that they sort of automatically provision and they automatically scale and are elastic as the service and the capacity on the networks change? Sorry about that. Where is that water? Oh well. So if I look at today, if I can make it work, oops, see my first mistake, went the wrong way. If I look today, I do a lot of local optimizations. I try and figure out, are you in a good RF condition? Are you getting good connectivity? But in the future, I'm going to actually put feedback loops into the network, and I'm going to look across the network end-to-end, from your device, through the base station, through the core, all the way to the application servers and the subscriber management systems. And I'm going to collect and analyze data, decide what to do it, and enforce decisions in the network. So the network optimizes itself to provide you with a better quality of experience. I'm going to make, rather than policy-based decisions, are you a gold, silver, platinum person? Did you pay your bill? Did you not pay your bill? Have you run out of data? I'm going to make decisions based on an orchestration of these functions throughout the network. That thing about whether you have used up your data may only be one component of a very complex decision that gets made about how to improve your quality of experience. And SON basically stands for self-optimizing networks. I'm going to take these networks and I'm going to run them free. I'm not going to have people in the way. They're going to sit back and watch the network do its thing. The network will actually optimize itself, look out, pull data, rearrange itself, and then basically go out, enforce that information to better drive performance. Once I've done that, I can look at clever other things I can do. Now that I've got an optimized network, a network that basically provides you with the best quality of experience, how do I monetize that? How do I say to an app provider, hey, I can guarantee you that I can get your information through perfectly, certain time, et cetera, without packet loss, pay me for it. I'd like a penny, okay? Can I do things like that? Can I do things like have an exchange where performance is traded off for financial benefit for everyone involved, right? Because these networks aren't cheap. They're not free. They're hundreds of billions of dollars goes into building this. I remember giving a talk one time at Boston University. I was asked, I got my degree there, and I said, you know, you guys just built a huge accelerator in Europe for $3 billion, and that's like the down payment on a mobile network. So, thank you. So we've got to be able to make sure that these networks and what goes through them come to a position of basically economic viability. The next topic, virtualization, orchestration. Today, we have dedicated hardware functions. And I'll show you in a minute how these fit together. Dedicated hardware functions. What we're going to do is separate software from the hardware, make the hardware common, off-the-shelf hardware, blade, for those that know what data centers are, blade servers, you know, basically x86 processors by the zillions on blades. And that will be the backbone of the hardware for the entire mobile network. Sure, we'll still have high-speed routing that will be required because there'll be functions in the network that are going at such a high speed in packet forwarding. We'll still have routers to do that, but that will be incorporated into the infrastructure. But basically, all of the mobility functionality I'll show you will be based sitting on x86 processing. And we'll also do things like today we hardwire how we configure things. As I said earlier, one of the things we want to do is make this automated, end-to-end. Not just automated in the optimization of the user experience, but automated in the configuration of the network. The one thing that we can't do in networks today is if I have a box and it has 3 or 4 functions in it, and one function hits capacity, it's good for Cisco because I sell poor AT&T or Verizon another hunk of hardware. But the problem is it's not elastic. It doesn't grow. And as each of those functions change, because what's happening, the one thing that is really daunting in running a mobile network now is every time user behavior changes, literally over days' time, the way we need to configure the network changes. What we call is it a call model, how you do what you do on a daily basis in the mobile network. So we're constantly modifying the network to try and keep up with your changing behavior and the network's changing behavior. And as a result, hard provisioning is very difficult to work with. So we want this network to be completely elastic. If it needs more of one functionality, it just grows. If it doesn't need it, it shrinks. Okay? Also, it's resilient, much more resilient. Failover methodologies are much simplified. I don't buy huge hunks of hardware in case one big huge hunk of hardware fails. So here's sort of the closed loop of the optimization. We're basically pulling information from all over the network, and I'll have a graphic on that in a second. We harvest the network intelligence. We do analytics on it at all levels. There may be analytics on the performance of a pipe in the network of some type of transport, the RF part. It might be also analytics on what you're doing at that given time. Are you looking at a video? Do we need to get your video through? Well, what is your video hitting a congestion point in the network? We then orchestrate that with policy. As I mentioned, policy is a big part of the network. What should we do? There are policies set in the network about you, about how the network performs, that we have to take a look at and make sure we fit within those constraints. and then we go back and program the network. And we do this in an iterative real-time feedback loop, and with no human intervention, although minimal. We always need humans, but with very little human intervention. This is your simplified mobile network of today. And I really mean simplified. This is all the high-level diagram of all the elements in a mobile network. We use this to basically scare Cisco executives, keeps job security, all that other good stuff. So out here is all of the macro network, the enterprise networks, all the small cells, Wi-Fi, you name it. In here is the transport. Here are the gateways that basically terminate these sessions. Here's all the network services. I'm sure many of you that are technical out there can recognize many of the different functions that are put here to work on the sessions as they come all the way through the network. Oh, by the humans and the cows and the farms and everything sit out here. And then you have up above here the optimization and service management and subscriber management functionality that goes on. And in here is where you see that loop. That loop is going around, pulling information out, going back and modifying it, right? And so this is basically what we want to automate. This very complex network, we want to automate. And I can tell you, we are doing it today. Huge steps forward have been made by many of the giant operators in the world, especially the two that were mentioned earlier, in this whole sort of automated scheme. So this is not, a pipe dream. This is all going on today and moving forward. SON, as we call it, self-optimizing network, is a real technology being deployed as we speak about it. It's not as elaborate as yet as I've pointed out here, but it will be within a few years. But on top of this, so look at all this complexity. Wouldn't it be nice if down here I could put all of this in the cloud? Now, there are two types of cloud. One cloud is the cloud out there that we put, our pictures and our movies and our family stuff in, and we worry about security of it. The other type is a private cloud, a cloud which is basically a data center with a lot of blade servers, virtualized infrastructure that the operator owns. Google owns data centers, AT&T, Verizon, they all do. And in that is where normally sits, along with all those blade servers, all this dedicated hardware. Why not we take all of this and put it on these blade servers? So what does that do for us? Well, we end up with a highly standardized hardware platform that is very cost competitive and also has the latest technology in it, because a lot of these hardware platforms, they're so expensive and so difficult to build and manage and design that you don't change them very often. Here, the latest and greatest x86 processor comes in, and if you've depreciated your data center properly, you can put it in, okay? So I have a platform that becomes sort of a utility. Here, I have my software. I've basically pulled the software out and I put it in a space where the entire software world is completely independent of the hardware world. And this is critical, right? Because this means not only can the software scale, but I remember getting in debates. You saw that network architecture. You can't believe how many of my people and my customers' people argue about that diagram on a daily basis. I said, look, if I virtualize it, wherever you put in x86, you want the node there, I'll put it there and we'll stop arguing. Okay? So you want a gateway for a mobile gateway in your laptop? Fine, I'll do it. Right? No longer do I have this debate of where I put things or what's the most efficient way to design the network. I can put the stuff wherever I want to put it, wherever I can put an x86 processor. And we're doing that today. We're moving stuff into the base station, moving stuff out of the base station. We're basically architecting the networks already quite differently because of this type of flexibility. And then finally, the big word. The big word used to be analytics. The big new sexy word is orchestration. How do I orchestrate all of this? How do I make this network? How do I do contention management? One app in the network wants some services. Another app wants services. How do I decide which one gets the resources that's there. Because even a data center isn't infinitely large. But the other thing is we'll be able to spread between data centers. We'll be able to say, your network is here, your network is in Tel Aviv, and your network is in Moscow. And only the speed of light inhibits me from doing that. So that component, that orchestration, you see throughout all discussions. It orchestrates down in the software, and we have orchestration going on in the user space around the optimization. So this is my data center. Those are Blade servers. I don't know which make they are. They're probably Cisco. But these are Blade servers. Think of them as just a bunch of x86 motherboards turned on end, right? And let's suppose, let me get to this one. Let's suppose it's 2 o'clock in the morning and a power company wants to read power meters and wants to use the AT&T or Verizon or Sprint, et cetera, network to do that. Sends in a request, and that entire diagram I showed you, except for the base stations, spins up inside of this Blade Center, everything. Everything you need to go read power meters. Now, probably don't need video optimization to read power meters, so that won't be spun up. And you see, that's a key point. I don't spin up everything. I just spin up what I need. I spin up all those gateways, all that subscriber management, all of those services get spun up in that to read those power meters. This is my consumer. This is the network that I use for my consumers every day. This is the lifeblood of a mobile network. And the danger has always been, if I wanted to add the power company, I'd have to add it to the consumer part of the network. Now, in the software space, not hardware space, think of this as software diagram, not a hardware diagram. In software space, this doesn't get touched by what craziness is going on over here. So I have separate networks running parallel, sitting on the same data center. This is the rest of that consumer network. I'll go through this quickly. I have an enterprise. The enterprise, Ford Motor Company, General Motors, whoever, Cisco, is running services on that net, in that needs a mobile network because it's using mobility for its customers. Well, I'll hit it easy. It's using mobility as a key component of driving the services to its customers and its customers and its employees. So it says I need a core, I need a network like I showed on that diagram. But I need more of it. Suddenly I have a surge in capacity and I need more of it. How do I do that? How do I deal with, as I said earlier, the network just grows. It encompasses more blades and it just automatically becomes bigger. So I have the ability theoretically to infinitely scale the capacity of my network. You did notice, one thing that you did notice is, it became 4 o'clock in the morning and the power company disappeared. Didn't need the network anymore. I redistribute that resources. That part of the network is gone. Power company can come back at a later date, fire its network up again. Alternate service provider, MVNOs for those that know the term. Other people wanting to come on and use that infrastructure. It's always been a pain to try and figure out how to add services, how to add machine to machine. So now we do it this way. Makes it almost trivial. And I don't want to, I want to be careful. I want to make sure people understand how strongly we feel about this. It takes sometimes months to put in what I call a packet core, provision it, set it up. We have demonstrations of setting something up and putting it in and having up and running with traffic on it in 30 seconds. So what am I doing? I'm reducing the total cost of ownership for my customers. And actually, I'm making my life a lot easier because it's a lot easier to build stuff in this domain. I have that enhanced scalability I said. I can dynamically manage all aspects of the network, and I can upgrade my hardware, almost at will within my financial ability. I can easily deploy new applications. This is critical to the entire, if I stop, Internet of Things, Internet of Everything idea. Without this type of technology, we probably wouldn't be able to really make it work, because it would be just too hard to figure out how to add hundreds of millions of devices, and it would be impacting the network that is the bread and butter. Now, by bread and butter, it's your bread and butter too. How many people get crabby when the network goes down, right? So what we don't do is we don't like to touch something that's working fine. This way, I can add things in without much effort at all. So every time I have a farm application, I have an agriculture application, I have an enterprise that wants to run that, I can fire it up with its own network. And finally, increased service velocity. Probably the biggest problem that I see is the rapidity of which we can change the network. Today, as I said a minute ago, it takes days, weeks, months to do things. And it also helps my customers. You know, we're in an internet world. We got these big honking boxes that I have to provision very slowly, whereas, you know, their competition is in the internet world. They're rapidly being able to change what they do on a moment's notice. The Googles, the Facebooks. Now the big service providers are in the same domain as them and are in a competitive space with how rapid they can change things in their networks. I want to put a little plug in. This is the AT&T Foundry that we helped AT&T launch. There are many of these. I am, in particular, personally believe this is a huge thing because I bought at least 2 companies as a result of these foundries. And it's a really great space. It's over here in Atlanta, down the street. And inside we'll have a bunch of nerds, if I can find my right button, sitting here basically working on the projects that are driving the technology I just showed you. We specifically will be driving the things I showed you a minute ago, the more advanced. We'll be bringing in students, interns, et cetera, to help the engineers we're sending down there to really drive these advances in the evolution of the mobile network of tomorrow. So I really want, please stop by, take a look. It's a very beautiful space with a bunch of smart people in it, with a whole bunch of really neat projects going on. So this is it. This is sort of basically what we're doing is enabling new value chains by connecting the unconnected. Basically, with this technology, suddenly we're able to go out and really say, whether it be devices, whether it be people, we now have a way to really scale mobile networks in a very efficient way to be able to connect everything into the mobile networks that we're struggling with today. Creating an enhanced quality of experience. I hope that you caught from the optimization component of the talk that we're going to be able to basically monitor what you're doing and improve what you're doing, what network you're on, and be able to make sure that the experience you're having is as optimized as the network can possibly make it with this huge influx of capacity and devices. And we believe that this use of network intelligence and service creation velocity will really help address the service provider challenges of the future. Really make the companies that provide you with your services today much more nimble and much more able to compete in this evolving world of mobility and the internet. And again, the idea is to, in the end, for all of us, the idea is that all of this, what it does is it enhances the end experience of the user experience of the end user. And with that, thank you. You're up.
Great. Thank you, Paul. Greatly appreciate that. I think we're off to a great start today. I think hearing from Paul really does set the foundation of the infrastructure that's required to make all of this work. As you know, sometimes we have to explain to people that, you know, the cloud's not in the cloud, and it takes a lot of wires to be wireless. And so as we move throughout the day, we're going to hear from more technologists, more people with the infrastructure, but also we're going to start hearing from more enablers like AirWatch and other people that are actually using the infrastructure that we Paul gave us a peek behind the curtain about how the magic works. We're going to see some great technology. We're all going to hear from some people that are really in the marketing, people that are really bringing this down to the citizenry, to the people, and even driving revenues with it. So Coca-Cola, IHG, Home Depot, and other brands. So we're delighted that you're all here. Couple things as we move forward. One, I mentioned our hashtag, Mobility Live. Please get some activity going on that. We are going, based on that, we're going to create a drawing. We're giving an LG phone away later today. We'll do a drawing on that, and it's based on the activity that you're doing on Twitter. But moving on from here, we're going to be going to our breakout sessions. One of those breakout sessions will be in this room, another one down the hall, and then two more upstairs, one floor. So with that, I wish you a great day. Learn a lot, share a lot, and I'll look forward to seeing us all back together at lunch. Thank you all.